Imagine you have devoted your life to studying the universe, and suddenly, you encounter a visitor that challenges all the fundamental laws you learned at university. Picture yourself meticulously observing its trajectory, emissions, and behavior, and nothing you perceive aligns with the equations you have reviewed countless times. As a scientist, I have experienced this sensation on rare occasions, but each has left an indelible mark on me. The first time was a few years ago with the appearance of Oumuamua, an elongated object that passed fleetingly without providing clear answers. The second occurred with the interstellar comet Borisov, which seemed like a conventional comet but carried compounds never seen before. The third, the most recent, is happening now with an object many know as 3I Atlas. This comet, if it can be called that, has accumulated so many anomalies that some sensationalist headlines claim it has broken the laws of physics. While this assertion may seem exaggerated, a review of the facts is sufficient to understand why the scientific community is shaken. In this account, I wish to share with you in detail what has happened, what has surprised us, and what we are learning. I will do so in the first person, as I have lived it, so that you too can experience the blend of awe, uncertainty, and excitement this interstellar visitor evokes. It all began on the 1st of July 2025. That day, the Atlas Asteroid Warning System, a network of telescopes funded by the National Aeronautics and Space Administration to monitor the sky and detect potentially hazardous objects, recorded a moving point of light. At first glance, it appeared to be one of the many small bodies traversing the depths of the solar system. However, it was soon discovered that its orbit did not match that of an ordinary asteroid or comet. Orbital calculations revealed it followed a hyperbolic trajectory, indicating it would not orbit the Sun but would pass through the system once before leaving forever. In other words, it was an interstellar object, the third recorded after Oumuamua in 2017 and Borisov in 2019. Its official name became 3I Atlas, where the I denotes the order of discovered interstellar objects. Unlike its predecessors, 3I Atlas gave us time. Oumuamua was detected as it was already moving away. Borisov appeared while approaching the Sun, but with less time for observation. 3I Atlas, on the other hand, was identified months before its perihelion, the moment it would pass closest to the Sun. This allowed the preparation of ground-based and space telescopes, coordination of observations, and anticipation of possible surprises. From the outset, it was determined that its speed was extraordinary, more than 130,000 kilometers per hour, making it the fastest object observed in the solar neighborhood. It was also estimated that its size spanned several kilometers, likely between 3 and 5. Initial measurements of its brightness and color described it as a faint comet with bluish hues, with nothing particularly out of the ordinary. The first clue that we were dealing with something exceptional emerged when analyzing its trajectory. 3I Atlas did not enter the system from just any angle. It did so almost exactly in the plane of the ecliptic, the band in which all the planets orbit. Most interstellar visitors arrive at inclined angles, crossing the orbital plane like projectiles. This one, however, followed the same path as Earth, Mars, and Venus. Moreover, its trajectory would bring it relatively close to these planets and later, to Jupiter. It was a statistically improbable coincidence. Some colleagues calculated that the probability of a random interstellar comet aligning with the ecliptic plane was 1 in 1,000. When adding the successive approaches to Venus, Mars, and Jupiter, the probability became infinitesimal. Curiously, its direction of origin in the sky was very close to the source point of the famous WOW signal, a radio burst detected in 1977 that has never been explained. This coincidence sparked all sorts of speculation. We soon discovered another peculiarity, the presence of an anti-tail or inverted tail. In ordinary comets, the tail forms because the solar wind pushes the dust and gas expelled by the nucleus in the direction opposite to the Sun. However, in the first images of 3I Atlas, captured by the Hubble telescope and the Gemini telescope in Chile, a gas jet was observed that appeared to be directed toward the Sun. Some suggested it might be an optical illusion. Dust grains ejected earlier were crossing our plane of vision, giving the impression that the tail pointed toward the Sun. However, spectra revealed a flow of carbon dioxide and carbon monoxide emanating directly from the illuminated hemisphere. This anti-tail surprised many. Comets in the solar system, when they have jets, typically exhibit them in the night side, not the day side. This anomaly, the second on the list, added to the orbital alignment and the direction of arrival near the WOW signal. While studying the jet, measurements of 3I Atlas's mass began to yield colossal values. Based on its speed and the effect of radiation pressure, We deduce that the object must be millions of times more massive than Oumuamua and thousands of times more massive than Borisov. Some estimates pointed to tens of thousands of billions of tons. For a comet expelling gas not to deviate, its mass must be substantial. However, the observed gas volumes did not align with the calculated mass. This discrepancy suggested that our model needed adjustments, or that we were dealing with an extremely dense or large nucleus. At this point, we had already identified three anomalies: the orbital alignment, the inverted jet, and the immense mass. The fourth anomaly manifested in the chemical composition. Solar system comets are primarily composed of frozen water mixed with carbon dioxide, carbon monoxide, methane, and ammonia. Typically, for every molecule of carbon dioxide, there are 3 to 4 water molecules. 3I Atlas, in contrast, expelled a quantity of carbon dioxide nearly 8 times greater than water. It was as if its nucleus lacked abundant water ice. Additionally, spectroscopic observations detected unusual metallic compounds. A team analyzing the light from its coma found nickel vapor and, even more surprisingly, nickel tetracarbonyl, a compound produced on Earth in industrial processes for refining metals. The absence of iron in equivalent proportions pointed to an unusual chemistry. Many wondered whether this nickel came from the surface or the interior. This unexpected composition became the fourth anomaly. The fifth anomaly was revealed when studying light polarization. Sunlight reflected by an object can be positively or negatively polarized, depending on the nature of the particles on its surface. Solar system comets show positive polarization at most angles, meaning the light oscillates in a preferred plane. 3I Atlas, however, exhibited extreme negative polarization. This indicates that the particles surrounding it have such an unusual internal structure or shape that they alter the light's orientation oppositely to what was expected. Negative polarization has been observed in some dust particles in specific environments, but never at this level in a comet. The sixth anomaly, related to the fifth, was the density of volatiles. The presence of carbon dioxide and cyanide, combined with the absence of water, suggested that the comet formed in a warm environment, possibly near a star, rather than an icy one. The seventh anomaly was detected using a specialized instrument: the amount of water expelled. Astronomers from the SWIFT mission used their ultraviolet telescope to detect hydroxyl radicals, molecules formed when solar radiation breaks down water. They observed that the water production rate was extremely low, barely 4% compared to other compounds. For a body presumed to have formed in the outer regions of a stellar system, this ratio was perplexing. The eighth anomaly emerged in October when a team from the Jet Propulsion Laboratory of the National Aeronautics and Space Administration detected that the comet was experiencing non-gravitational acceleration during its approach to the Sun. Calculations based on slight variations in its position indicated that its speed changed by more than 100 km per day squared in the radial direction and tens of kilometers per day squared in the transverse direction. This acceleration could not be easily explained by gas jets unless the comet was losing a massive fraction of its mass in weeks, which was not directly observed. With this accumulation of anomalies, many began to speak of a comet that seemed to defy the laws of physics. Some media published sensationalist headlines: 3I Atlas breaks the laws of physics. Others speculated whether it might be a disguised interstellar spacecraft. Avi Loeb, an astrophysicist from Harvard University known for his openness to bold ideas, calculated the combined probability of each anomaly and concluded that the likelihood of all occurring in a natural comet was extremely low. He proposed considering the hypothesis that 3I Atlas might be an artifact created by an extraterrestrial intelligence. He argued that an artificial object could explain the alignment with the ecliptic, the sequence of planetary approaches, the inverted jet, the immense mass, the nickel-rich composition, and the negative polarization. Not everyone agreed. Other scientists, like Tom Statler from the National Aeronautics and Space Administration, reminded that each comet is unique and the conclusions should not be drawn without definitive evidence. As the debate about its nature intensified, perihelion arrived. On the 29th of October, 3I Atlas reached its closest point to the Sun, approximately 1.36 astronomical units away. During that period, it was behind the Sun from our perspective, so ground-based telescopes could not observe it. However, solar probes like Stereo A SOHO and GOES continued monitoring. What they detected left everyone speechless. According to reports, the comet's brightness increased dramatically, far faster than our models predicted. The light intensity followed an inverse relationship with the distance to the Sun raised to the power of -7.5. This means that as the distance decreased, the brightness multiplied disproportionately. In comparison, solar system comets typically follow an inverse relationship with powers between -2 and -4. 3I Atlas far exceeded this trend. Additionally, it acquired an intense blue color, bluer than the Sun, which physicists could not explain. Ordinary comets show red or yellow colors due to dust. The blue indicates emissions of ionized gas at very high temperatures or unknown processes. This color change and unprecedented brightness were considered the ninth anomaly. Avi Loeb, interviewed by a media outlet, admitted to being surprised. He said he expected some peculiarities, but seeing the comet bluer than the Sun was stranger than I imagined. He added that he did not understand the origin of that color and that neither he nor his team had had time to decipher the physics behind it. His phrase resonated in the community. What is this comet doing? Why does a body colder than the Sun appear bluer? Let us recall that the surface temperature of the comet's nucleus is around a few hundred degrees, while that of the Sun reaches nearly 6,000 degrees. A bluer light implies that the particles in the coma are excited to higher levels than expected. One might think the explanation lies in the sublimation of exotic compounds, but the magnitude of the phenomenon remains incomprehensible. Some suggested the comet may have collided with a small body or passed through a particularly intense stream of solar particles. Others proposed that it had fragmented, exposing an interior rich in rare compounds. However, the images showed no fragmentation. What they revealed was an immense gas cloud extending hundreds of thousands of kilometers around the comet. This cloud appeared to contain ionized carbon dioxide, carbon monoxide, and small amounts of other compounds. Solar missions also detected disturbances in the magnetic field around the comet, suggesting that the expelled gas was interacting with the solar wind. Amid this avalanche of data, news emerged that the comet had become retrograde relative to the planet's motion. In other words, it seemed to move in the opposite direction to the planet's rotation around the Sun. This claim, which circulated on social media and some blogs, was not entirely accurate. In reality, 3I Atlas's orbit was always retrograde, as it travels counter to the planet's motion. However, some interpreted it as a sudden change in direction, which would be impossible without a colossal force. It was also claimed that the comet violated Newton's third law by accelerating without expelling mass. This is not accurate. If the acceleration was due to jets, the law of action and reaction was upheld, but our instruments may not have detected the gas because it consisted of transparent or ionized molecules. The 10 accumulated anomalies gave rise to eye-catching headlines. 3I Atlas breaks the laws of physics. From my perspective, it is not about breaking the laws but challenging our understanding. The laws of physics remain valid, but our specific comet models did not account for these behaviors. If a body aligns with the ecliptic, travels retrograde, changes color, expels nickel, shows extreme negative polarization, and accelerates without apparent gas expulsion, it does not mean it violates Newton's laws or thermodynamics. It indicates there are processes we have not considered. Our responsibility as scientists is to identify those processes, adjust our equations, and if necessary, propose new theories. In the months following perihelion, the scientific community has split into several stances. One group attempts to explain each anomaly with natural phenomena. The alignment could be a coincidence. The anti-tail, a carbon dioxide jet, the immense mass, a dense nucleus, the acceleration, mass loss through sublimation, the blue coloration, ionization of excited gases, the negative polarization, unusual particles, the direction of arrival, mere statistics, the coincidence with the wow signal, a correlation error. Another group considers the possibility that we are observing technology. They suggest the jets are thrusters, the alignment follows a planned itinerary, the mass is large because it contains a hull and internal compartments, and the anti-tail is a brake. This case recalls Oumuamua, which some described as a solar sail. Though a minority, this stance has gained visibility through media-seeking headlines and communicators willing to explore bold hypotheses. Between these two positions, there is a third group, to which I belong, that combines curiosity with skepticism. We believe nature can offer extraordinary spectacles that should not be ruled out. But we also consider that data must be interpreted carefully and that, at times, unconventional ideas need to be considered. It is not about discarding the laws of physics, but exploring whether they require new approaches. This is how revolutionary theories have emerged throughout history: Einstein's relativity, quantum mechanics, the general theory of relativity. Many of these revolutions were born when phenomena did not fit existing laws. A comet that turns blue, aligns oddly, and changes speed could be the prelude to a revision of our models on the formation and dynamics of interstellar bodies. For now, research continues. The comet is moving away from the Sun but still offers observation opportunities. Its closest point to Earth will be in December, when it will be about 170 million kilometers away. Then, it will head toward Jupiter and exit the system. Space missions plan to observe it during these months. The European JUICE probe will be able to measure its surface temperature and detect possible cavities. The Juno orbiter could capture microwave emissions and detect thermal anomalies. The Hubble telescope will attempt to discern the nucleus's structure and the distribution of its jets. And the James Webb telescope, with its infrared sensitivity, will search for complex organic molecules. Each of these observations will help refine theories and rule out some of the more speculative explanations. Meanwhile, the scientists and enthusiasts following this phenomenon reflect on what we have witnessed. 3I Atlas has taught us that the universe is more diverse than we imagined. It has shown us that comets can exist with chemistry dominated by carbon dioxide and nickel, with trajectories perfectly aligned with the plane of the planets, and optical behaviors that seem illogical. It has emphasized the importance of keeping an open mind, but also demanding rigorous evidence. And it has demonstrated that science is a work in progress, capable of adapting to the unexpected. The claim that 3I Atlas has broken the laws of physics is, ultimately, a metaphor for our surprise and humility. The laws of physics, as we understand them, are frameworks that allow us to explain and predict. When a phenomenon does not fit, it does not mean the laws are false. It indicates missing information or a different scale than explored. The comet reminds us that our theories are based on limited observations and that, when facing the unknown, we must be prepared to revise them. The fascinating part is that we can all participate in this discovery, whether by observing the sky, reading reports, or letting our imagination soar. I wish to conclude this account by inviting you to embrace the wonder of the unknown. Perhaps 3I Atlas is a natural comet with exotic properties. Perhaps it holds clues about how worlds form in other stellar systems. Perhaps it is an artifact, a spacecraft, or a probe sent by unknown intelligences. In any case, it offers us a lesson. The universe is vast, surprising, and unpredictable. If this story has captivated you, if you feel the search for answers is worthwhile, I invite you to share this account, support it, and continue exploring with me. For while it may seem that the laws of physics are breaking, what is truly opening is a window to deeper knowledge. And that adventure, for lovers of science and mystery, is simply irresistible.